All right, thanks for joining. So what we're going to do to get started is you're going to grab your spiral notebook, okay? And we're going to title a new page, Solving Compound Inequalities. So we're going to add on to what we were doing in class when we were learning about how to graph and or inequalities. So our first example is going to be with the conjunction or. And so I've got x plus 20 is greater than or equal to 32, or we have 1 minus 8x is greater than 17. Okay, so with the or inequalities, we're pretty much going to solve each inequality separately, and at the end, we'll graph it together on a number line. So I'm going to begin by subtracting 20 from both sides, okay? And we're going to get x is greater than or equal to 32 minus 20, which is going to be 12. Well, now this inequality is solved for. So let's come over to our second inequality. And now we have a little two-step inequality. So we're going to begin with minusing the 1 from both sides. And we're going to get negative 8x is greater than 17 minus 1, which is 16. So now looking at this, we're going to divide both sides by negative 8. And one of the trickiest things with inequalities is we need to remember, right, when we divide by a negative, we are going to flip this inequality, okay, and this is going to become a less than. So 16 divided by negative 8 is 2. And so we'll make a note of this when we're finished about when we multiply or divide by a negative, we are going to flip the inequality. All right, so I'm going to do is I'm just going to bring this down a step, okay? So we have x is greater than or equal to 12, or x is less than negative 2. So what we're going to do is we're going to graph this on a number line. And now we're picking up to what we were learning in class about how to graph our and or inequalities. And so what we do again is we're going to take the first inequality and I'm going to graph this one in blue. So it's going to be a closed circle, x is greater than or equal to 12. I'm going to take the second inequality and I'm going to graph this in green. And this is going to be an open circle, x is less than 2, so we're going to shade everything to the left. Now recall that when you have an or inequality, your solution is going to be the combined sections of both the inequalities. So it's going to be the green one, plus it's going to be the blue one. So these are my two sections, okay? As opposed to the and inequality where we shade the overlap. And so our solution is going to be negative infinity to negative 2 with a parenthesis. And again, that parenthesis because of the open circle. Union bracket 12 to infinity. Okay? So again, we always write our interval notations in order from the left side over to the right side, the same way we would go across the page and read a book. Okay, let's take a look at our second example. 5 times x plus 4 is greater than or equal to 5, or 2 times x plus 4 is less than 12. Okay, so again, we go into this and we just solve each inequality individually. So I'm going to start by distributing. 5x plus 5 times 4 is greater than or equal to 5. Okay, so we've got this little two-step inequality. I'm going to subtract 20. Now, minusing a number from both sides does not cause our inequality to flip. This is 5 minus 20, so it's going to be negative 15. So now I'm dividing by a positive 5. And because I'm dividing by a positive 5, I do not flip the sign. Even though the result is negative 3, again, I divided by a positive, so I do not flip the sign. So let's come down here. Let's come over here, and we're going to distribute and get 2x plus 2 times 4. Okay? We're going to subtract 8 from both sides, and we get 2x is less than 12 minus 8. Again, I'm dividing by a positive, so I do not need to flip the sign. And so this time, I'm going to graph our compound inequality, which I need to also bring down the word or. Okay, we're going to graph our compound inequality. So we've got negative 3 and 2. We've got a closed circle on the negative 3, an open circle on the 2. So like we were doing in class, your first inequality I'm going to graph in blue. And I'm going to graph everything greater than or equal to negative 3. Okay? Our second inequality I'm going to graph in green. And this is going to be an open circle, x is less than 2. Now, because of the or, I'm going to shade the combined sections of both inequalities. It's going to be everything greater than -3 that's covered with the blue, plus everything covered with the green, which is less than 2. And so what I end up shading is the entire number line, which is going to be -infinity to infinity, okay, for my solution. That means infinite solutions. Every single number on the number line is possible. Okay. So let's look at example 3. Okay, example 3. So now next two examples we do are going to be your and inequalities, okay? Well, the first one's a little bit different because you're not going to physically see the word and, but it's assumed that it is an and. So you can just watch for now. The first thing I'm going to do is I want to kind of show you where these two inequalities come from. So again, you don't need to write this down. I just want you to look and I want to make sure you understand. The first inequality is this one right here, okay, if you can see this one. And what that means is it's going to be -3 is less than 2x plus 7. Your second inequality is going to be this one. And what you can see is they overlap, okay, with the 2x plus 7. And these types of inequalities are always assumed to be and, which means we're going to shade the overlap. And so what I would do if I was solving this one is I would -7 from both sides. But also, if I was solving the one in green, I would also -7, okay? So that's just kind of what it looks like and what we're doing. I just want you to see before I solve this and I show you the shortcut, I want you to understand that we're really solving two different inequalities. All right, so now I want you to grab your pencil and let's solve this problem. This is where I'm going to start, is with 2x plus 7. So I'm going to start by subtracting 7. We're going to -7 from the far left inequality, but we're also going to -7 from the right inequality. So -3 minus 7 is going to be -10, less than, here the 7's cancel, and I get 2x less than or equal to 10 minus 7 is going to be 3. Okay, so now I look in the middle again and I think, how do I get x by itself? Well, it's 2 times x, so we're going to divide by 2. But we're going to divide each inequality by 2. And so I have -10 divided by 2 is 5, less than x, which is less than or equal to 3/2. Okay, so when we graph this on a number line, what we're really doing here, and we can put this in order, we have open circle on -5, and for 3/2, it's a closed circle. But the easiest way to shade these inequalities where x is between -5 and 3/2 is to literally shade in between these two. And that's all you're going to shade, because what we're really doing is shading the overlap of the two inequalities, but the shortcut is to just shade in between those two numbers. And so the interval notation is going to be from parenthesis -5 to 3/2 with a bracket, okay? And that was because of the open circle over here and the closed circle over here. All right, so I just have one more example. Let's look at one more and see how this one's gonna work out, okay? -4a plus 9 is less than 1, and 7a minus 13 is less than or equal to -6. Okay, so we're going to solve each one at a time. And so we're going to start this one by subtracting 9 from both sides. And this is going to cancel. I get -4a is less than 1 minus 9, which is -8. So we're going to divide both sides by -4. Now here's where we need to be careful. We're dividing by a negative, so we need to flip the inequality, and -8 divided by -4 is a +2. So again, it doesn't necessarily matter what your solution is, if it's positive or negative, it's when you divide by a negative. All right, let's switch gears. Let's come over here and let's solve this little two-step inequality. I'm going to start by adding 13, and we get 7a is less than or equal to -6 plus 13, which is 7. Divide both sides by a +7, sign stays the same, 7 divided by 7 is 1. Okay, so let's graph this inequality. So again, this first part, set up your number line, put the numbers in order of their distance from 0. It's going to be a closed circle on the 1. It's going to be an open circle on the 2. So just like when we were in class, let's shade each inequality. A is greater than 2 is going to be everything shaded to the right. But A is less than or equal to 1 is going to be a closed circle with everything shaded to the left. Well, again, because of this word and, okay, we need to shade the overlap. And these two solutions do not overlap. And so what we're going to have is, this is that case that we talked about in class. This is a no solution. Okay, so what we're going to do to end these notes is, we've got so many little things that we have to remember about open circle, closed circle, brackets, parentheses, but we also, the most important part is need to remember the difference between an and or an or. When we have an or, your solution is the combined sections, okay, of both inequalities. And so like we said, if we do the first one in blue and the second one in green, your solution is going to be the green one plus the blue one. But the ands, on the other hand, okay, you shade the overlap only. So we just really need to think about it when we're graphing rather than just, quickly looking at it and assume that we have the solution. And the other important thing that I want to write down before we finish is when you divide or multiply by a negative number, okay, you need to flip. We're going to make this kind of emphasized here. You need to flip the inequality. And that just comes from paying attention, and that just comes from practice, okay? So those are kind of the big bullet points: how to graph an or, how to graph an and that reminder about when to flip the inequality, okay? Well, that's it, and we'll see you next time in class. Bye.